Hello, today we are going to be working with the concept of molarity. It's a way to express concentration of a chemical compound. Now, sometimes you're going to see your unit as a capital M, and also sometimes you'll see molarity used with the squared in brackets. Anytime you see one of those, then you're going to be dealing with molarity. Now, molarity has its own formula. So you have molarity, it's equal to moles of solute over liters of solution. And there are ways to shorten this down. So you can have, sometimes you'll see the formula as capital M equals MOL for moles of solute over L for liters of solution. And then when you take that, then you can put it into one of those magic triangles if you'd like to. You don't have to, but for me it's a little bit easier. So I'm going to do capital M equals mole over liter. And let's make that where you can actually read it. And it's going to be mole over liter. Your units for this, you're going to see it as a capital M, but that also can be written as mole over liter. Strangely enough, that gives you your formula again. Either of those concepts or either of these units can be used depending on the problem that you've got. Now, before we go too far into molarity, it's important to kind of go back and do a little bit of a review from physical science or from wherever. Compounds can be, matter can be classified as an element, a mixture, or a compound. And really what we're looking here at is we're looking at mixtures. And mixtures can have one of three. You've got your suspension, a colloid, and a solution. And a solution is really what you're looking for. That's what we're dealing with these things, with these formulas. So really a solution, if you will remember, can be made up of a solvent and it's added to a solute. Or sometimes people say it's a solute. A solvent and a solute are two different things, and one easy way to kind of remember what is what is if you draw this little glass. Okay, so you've got this glass, and the V, I guess we'll do it this way really to make it a little bit easier. The V portion stands for the solvent, and it does the dissolving. And the V helps remind me. And then the solute are these little U ice cubes, and they get dissolved. Now, why does that matter in this formula? Well, it matters in this formula because you've got molarity equals mole of solute over liters of solution. So when you're really looking at it, the solute is the stuff that's getting dissolved, and then for the liters of solution, that's for everything. That's for both. So it's for the total solution. You're not having to subtract out anything there. So let's take a look at a few practice problems. There are some simplistic practice problems that you'll see, and then there are some that have a few twists to them. They really are not that complicated. It's just a matter of realizing what you do with your variables. When you're dealing with any kind of word problem, I'm always going to suggest that you take a look at your variables. What has actually been given to you. So, says, what is the molarity? Well, that's my clue of what it is I'm looking for, so I'm going to put that down with a question mark. And then it says that you've got a 575 milliliter solution. Now the solution, if you remember, is everything together. So that's going to be your volume, and so I'm going to put there with an L, and it's going to be 575 milliliters. Now if you notice, the variable is listed as an L, and that's not what I have. I've been given milliliters. So you're going to need to convert that to liters, and in this case you're just going to move the decimal point 3 places to the left. So you're starting out with a small unit and you're going to a larger, so you're going to move it 3 places to the left, and then that's going to give me my volume as 0.575 liters. And then it tells you that it contains 3.2 moles of sodium chloride. Alright, well, it gives me my moles, which is nice. So it's going to be 3.12 mole of NaCl. The question that I always get is, does the substance matter? Well, it does. In this particular problem, you don't really have to do anything with it, which is nice. But in the future, you're probably going to have to, and if you've got my class, you're definitely going to need it. So I'm looking for my molarity. I have my liters and I have my moles. So I look, and my formula is going to be molarity equals mole over liter. So we do what I call plug and chug, and so I'm going to have 3.12 mole, and it's going to be divided by 5.75 liters. So when you run the math on that, it's going to come out to be a molarity of 5.42. Actually, when you round it, I apologize, it's going to be 5.43 molar, and that's going to be your concentration. And really a better way to write that is going to be your molarity equals 5.43 molar NaCl, and sometimes you'll see that written in a bracket. And again, the bracket is just a chance, or it's a signal to say, hey, we're dealing with concentration. And when you're looking at that particular number, what does 5.43 mean as far as molarity and concentration? Essentially, that's telling you that it's almost 5.5 times stronger than the base concentration, which would be essentially a 1 molar solution.